Hey guys, we started talking about factoring in class today. We talked about grouping and greatest common factor. And so in this video, we're going to talk about how to use trinomial factoring when you have three terms in a quadratic, meaning you've got that squared variable. So, we used GCF as kind of like a first stop. Always check for a GCF first. And then if you have four terms, you're going to group. Well, now we've got three. And there's two different types of trinomial factoring, two different things that you can do when you have three terms. And we're going to talk about one of them right now. So the purpose, as we know, as we have discussed, the purpose of factoring is to break up the three terms into two groups of two terms. And those are factors that you can then multiply back together to get the original trinomial that you were given. So trinomial factoring will work if your expression is in the standard format, or I'll write it again here, ax squared plus bx plus c, standard form. Okay, and the number in front of the squared variable, so the a value, if the a value is 1 and thus not written. Regular trinomial factoring will only work when you have your expression in standard format and the value of a, or the number in front of the x squared, is 1. Since it's not written, we can call x squared and make it variable. You won't see anything attached to it. It's not wearing any clothes. Okay, so in order for us to actually do this type of factoring, we need to figure out two numbers. And those two numbers have to multiply to equal the c value, as well as add to equal the b value. So multiply to equal c and add to equal b. The same two numbers have to fulfill those two constraints. They have to be able to multiply to c and add to b. Okay. So let's take a look at an example here. We've got x squared plus 7x plus 10. We are in the appropriate format. We do not have a coefficient here. We have an invisible 1. That's perfect. I've got a naked x squared. So the first thing I'm going to do is write my two sets of parentheses, just like that. Okay? My next step is to split up the variable, the x squared, evenly into each set of parentheses. So if I have x squared, I effectively have x times x. That means I'm going to take 1x and put it in the first set of parentheses, and 1x and put it in the second set of parentheses. All right? I'm going to repeat that down here. X and x. What two numbers multiply to 10, because 10 is in the C position. Remember, this is A, B, and C. So what two numbers multiply to 10 and add to 7? Think about the factors of 10. What do I have to multiply together to get 10? 10 times 1? Well, that's great. That multiplies to 10. But if I add those things together, I get 11. So that can't be right. What's next down the line? 5 times 2. If I multiply 5 times 2, I get 10. If I add 5 plus 2, I get 7. So those are the numbers that I'm looking for, 5 and 2. I'm going to put one of them here. I generally put the bigger number first. Then I'm going to put the other one here. They both have to be positive, so I'll give them both plus signs. That's it. That, right there, those are the factors of x squared plus 7x plus 10. How can I check to make sure that I did this correctly? Well, this should look familiar. This is a binomial times a binomial. I can multiply them together, and I should get a trinomial, and I bet we'll get that if we multiply them together, so let's try. I'm going to FOIL, so my first term, x times x, is x squared. My outside terms, 2x. My inside terms, 5x. And my last terms, 10. X times x is x squared, 2 times x is 2x, 5 times x is 5x, 5 times 2 is 10. I can combine like terms, and wouldn't you know, I'm right back where I started. That means I have factored correctly. My answer is x plus 5 and x plus 2. Those are the two factors that I have to multiply together to get this expression. Okay, that's it. That's trinomial factoring. As long as you don't have a number in front of the x squared, this is all you have to do. Not too bad. And I know you've seen it before, so this should not be surprising. Let's take a look real quick and just remember some of these helpful sign hints for when we're figuring out our numbers. Okay, so if the C value, I'm going to write this again down here. I mean, short of getting it tattooed on your body, you must commit this to memory however you see fit, okay? If the C value is positive, okay, so if you have a plus sign in front of the C value, then the signs in both of your sets of parentheses will match. They'll be the same. And we use the sign in front of B to figure out what sign we're going to use. So if you have a plus sign in front of C, both signs will be the same, and they will both be plus signs because that's what's in front of B. You'll have x plus and x plus. And that's exactly what happened up here with our example. We had a plus 10, which meant we were going to have the same signs, and since we had a plus sign in front of B, those were the signs we used. Okay? In this case, we have a plus sign in front of C, which means our signs will match, but it's a subtraction sign in front of B, which means the matching signs we're going to use are going to be subtraction signs. All right, so if you see a plus sign in front of C, just look to B to figure out what sign you're putting in both sets of parentheses. If it's a plus, you get pluses. If it's a minus, you get minuses. Now, if the C value is negative, it's a little more complicated, but nothing we can't handle, okay? If I had the same signs with a positive C, then a negative C will give me different signs. Each of my parentheses will have a different sign. So whichever sign is in front of B is the sign that will get stuck to the bigger number. Think that B is the letter that starts the word big. So whatever is in front of B gets the bigger number. Here I've got x squared minus bx minus c. I know my signs are going to be different because there's a minus right here. And since I've got a minus sign in front of B, then it will be x minus the bigger number and x plus the smaller number. And vice versa, if I have a minus sign in front of C and a plus sign in front of B, then it will be x plus the bigger number and x minus the smaller number. And that's kind of one of the reasons why I like to get in the habit of always putting the bigger number in the first set of parentheses. So then this can just kind of be routine. You know your bigger number is always going to be there, so is it going to get a minus or is it going to get a plus? If you're kind of like all willy-nilly with where you put it, it's going to be a little bit harder to keep track of those sign rules. All right, so let's take a look at a couple more examples here in your packet. All right. X squared plus 3x minus 10. I'm going to make my two sets of parentheses, and I'm going to consider my sign. All right? I have a subtraction sign, which means my signs will be different. And I have a plus sign in front of B, which means my bigger number that I put in the first set of parentheses will get a plus, and my smaller number will get a minus. So what two numbers multiply to negative 10 and add to 3? Well, it's not 10 and 1. It's, again, going to be 5 and 2. But which one is negative and which one is positive? The bigger number will get the plus. So x plus 5 and x minus 2. 5 times negative 2 makes negative 10, and 5 minus 2 makes 3. Okay? Let's try another one. I'm going to make my parentheses and consider my signs. Sorry, I left the staple in here and it was proving to be the wrong move. All right, here's an x and here's an x. I've got a subtraction sign, which means my signs will be different. And it's a subtraction sign in front of B, which means the bigger number will get the minus. So what two numbers multiply to negative 14 and add to negative 5? Well, let's think about the factors of 14. 14 and 1 do not in any way add to 5. But 7 and 2 7 times 2 makes 14, and 7 minus 2 makes 5, but I want a negative 5. I'm going to give the subtraction sign to the bigger number, and that way, negative 7 times positive 2 makes negative 14. Negative 7 plus positive 2 gives me negative 5. Okay, let's try this guy down here. X squared minus 9x plus 20. I've got my parentheses. I'm looking at my signs. I've got a plus sign, which means my signs will be the same. I've got a subtraction sign in front of b, which means both will get subtraction. So how can I get positive 20 and negative 9? Well, a negative times a negative will equal a positive. So what's going to make 20? 20 and 1, yes, but negative 20 and negative 1 is not going to make negative 9. 10 and 2, yes. Negative 10 times negative 2 will make positive 20, but we can't get that to make negative 9. So how about 5 and 4? Negative 5 times negative 4 will make positive 20. Negative 5 plus negative 4 makes negative 9. And if you have to, don't be afraid to make a little table. You know, I'm trying to make positive 20, so I can do, knowing that I've got two negatives, I can do 20 and 1, I can do 10 and 2, I can do 5 and 4, and then go down the line and add them up. Well, this makes negative 21, this makes negative 12, okay, this makes negative 9, this must be the one I want. And then I can fill them in. Nothing wrong with that. I'm not going to judge your process. I'm only going to judge your final answer. So as long as you get it right, I really don't care how you get there unless I specify on the question that you have to show me something in particular. But otherwise, if you need to make a table, make a table. Make all the tables you want. Okay, let's try this last one. X squared plus 12x plus 36. This should be a no-brainer because we know our perfect squares. We remember them from algebra, but just in case, let's give it a try. I've got a plus sign in front of my C value, which means my signs will be the same. I've got a plus sign in front of B, which means both signs will be that. What two numbers multiply to 36 and add to 12? It's 6 and 6, you guys. 6 and 6. X plus 6 times x plus 6. And for any of these, if you're ever unsure of your factoring, just FOIL them back together, okay? X times x for my first terms, x squared. My outside terms, x times 6 gives me 6x. My inside terms, 6 times x gives me 6x. And my last terms, 6 times 6 gives me 36. I can combine these like terms together. X squared plus 12x plus 36. That'll work on any of these as long as we have factored correctly. All right, guys, we're going to do a bunch of examples of these in class. Pause this video, rewind it if you need to, write down any questions you have. You know the drill. I will see you tomorrow, and we'll get cracking on some examples. Great job.